Good afternoon. This is Nuclear Plant Components. And we are working our way through our study of diesel engines. So we left off our last lecture discussing fuel systems. So we will pick up today with air intake system. So the air entering the diesel engine must be clean, free of debris, and as cool as possible. The intake system is designed to take air from as far away from the engine as practical. This is to ensure the entering air is as cool as possible and has not been heated by the engine's own waste heat. And the point of this is, or the purpose is because cool air is denser than hot air. This means per unit volume, cool air has more oxygen than hot air. And remember, oxygen is the fundamental basis of a combustion, which means more oxygen that is available then the more power that is achievable. So we have wet versus dry filter intake systems. For a wet filter intake system, the air is sucked or bubbled through a housing that holds a bath of oil such that any dirt in the air is removed by the oil in the filter. The air then flows through a screen type material to remove any oil that may be entrained in the air. In a dry filter system, paper, cloth, or a metal screen is used to catch and trap dirt before it enters the engine. So this is very similar to your vehicle engines. The air filters you have to replace on some frequency every 6 months or so to protect your engine and make sure debris does not enter. So after being filtered, the air is routed by the intake system into the engine's intake manifold. The manifold directs the fresh air to each of the engine's intake valves or ports. Remember, we need the fresh air to aid in the combustion process. Let's go with some terms. Turbocharging compresses the intake air to the engine. It serves two functions. One, it increases the engine's available power by increasing the maximum amount of oxygen that is forced into each cylinder. This allows more fuel to be injected and therefore more power to be produced by the engine. The second function increases intake pressure, which improves the removal, or sometimes termed scavenging, of exhaust gases out of the cylinder. Now, supercharging performs the same function as turbocharging, with the difference being the source of power used to drive the device that compresses the incoming fresh air. In a supercharger, the air is compressed in a device called a blower. And for a turbocharger, the engine's exhaust gases drive a small impeller which is connected to a second impeller in the fresh air intake system. The impeller in the fresh air intake system compresses the fresh air. Exhaust system. So the exhaust system of a diesel engine performs three functions. Firstly, it routes the spent or the used combustion gases away from the engine. Secondly, it confines and routes the exhaust gases to the turbocharger if applicable. So if one is present in the system. Lastly, it allows mufflers to be used to reduce engine noise. So now we're about to get into the engine power cycle. This will require us to define some more terms, and then we'll get into the cycle. So let's define some terms. Bore is the diameter of the engine's cylinder. Stroke is the distance the piston travels from either the top of the cylinder to the bottom, or the bottom of the cylinder to the top. Engine displacement equals to the total volume displaced by all the pistons during one stroke. And the units for volume of cylinder from a geometry class, the formula for a volume of cylinder is pi r squared h, and then r, which is radius, is 1/2 the bore, which is diameter. And h would be the stroke distance. Degree of crankshaft rotation all events that occur in an engine are related back to the location of the piston. And because the piston is connected to the crankshaft, any location of the piston corresponds directly to a specific number of degrees of crank shaft rotation. Firing order. This refers to the order in which each of the cylinders fires, or their power stroke in the cycle. For example, an engine firing order could be which means the order of the firing is the number one cylinder fires, then the four, then the three, then the two. Engines are designed so that the power strokes are as uniform as possible. Clearance volume is the volume remaining in the cylinder when the piston is at top dead center. Top dead center, highest point of travel by the piston bottom dead center lowest point of travel by the piston in the cylinder. So an engine's compression ratio takes the volume of the cylinder with the piston at bottom dead center, the lowest point the piston can go in the cylinder, and dividing it by the volume of the cylinder when the piston is at top dead center. So let's show you what I mean. So in this case, this is the piston at bottom dead center. This piston is at top dead center. So this is the lowest the piston can travel in the cylinder, and this is the corresponding volume. This is the highest the piston can travel in the center, and this is the volume that's left, which we term the clearance volume. So in the compression ratio then, and what we're saying is when the piston's at bottom dead center and the chamber is filled with the air, as you compress, slide that piston moves upward. Piston moves upward. That volume of air is compressed, which means the volume has decreased and the pressure and temperature are increasing. So then the compression ratio, if this is some amount of units of volume and it then decreases to this, that's what we mean. So if we say, hey, at bottom dead center, this volume in the chamber or cylinder is equal to, let's just say this is 20 unit volumes. And then once it's at top dead center, the piston that is, you're left with, say, 1 unit volume. Then that's your compression ratio. How much the piston or how much the air has compressed. So we'll say 20 to 1. Talk about horsepower. Power is amount of work done per unit time. So it's the rate of doing work. Brake horsepower is the amount of usable power delivered by the engine to the crankshaft. So basically by the pistons to the crankshaft. indicated horsepower is the power transmitted to the pistons by the gas in the cylinders. The difference between these two horsepowers, indicated versus brake, is attributed to engine friction, combustion inefficiencies, and internal losses. The ratio of engines' brake horsepower and its indicated horsepower is called the mechanical efficiency of the engine. Another term, torque, is a measure of the engine's ability to apply the power it is generating. So let's talk about the diesel cycle, which we've been building up to all along. Remember, once again, it's an internal combustion engine. And in this, we'll cover the two-stroke cycle versus four-stroke cycle. And we meant by stroke is when the piston moves from top dead center to bottom dead center, or when it moves from bottom dead center to top dead center. So diesel engines, say cycle, must go through the following events. And there are 5 of them. You have intake, compression, ignition, power, exhaust. And then it repeats. This is the cycle. Intake of the fresh air, compress the fresh air, ignite the air. This creates the power, and then you exhaust the spent gases. Then the cycle repeats. Intake the fresh air, and so on and so forth. So we're going to talk about 4-stroke versus 2-stroke. So for 4-stroke, the engine requires 4 strokes of the piston to complete one cycle. And the cycle being, like we just said, intake, compression, ignition, power, exhaust. So it takes 4 strokes of the piston to complete this. So 4 strokes then means 2 rotations of the crankshaft. Each rotation of the crankshaft equals 360 degrees, circle. So then 2 rotations mean crankshaft has experienced 720 degrees of rotation. So when piston is fully up in the cylinder, this is top dead center. When piston is fully down, it is called bottom dead center. And that's 1 stroke. And we said 1 rotation of the crankshaft (360 degrees) is 2 strokes. Right? So 1 stroke from top to bottom and a stroke from bottom to top. 2 strokes, 1 rotation of the crankshaft, 360 degrees. So when the piston travels 180 degrees, either from top dead center to bottom dead center, or bottom dead center to top dead center. That's 180 degrees. If the piston moves 90 degrees from top dead center to bottom dead center, it is halfway there, and vice versa. So if the piston is approaching, let's go to another page. If a piston is approaching top dead center, then we use the terminology some amount of degrees, depending where the piston is, before top dead center is BTDC. So if the piston is moving upwards, then it's some amount of degrees before top dead center. So if the piston is approaching bottom dead center, then we say some amount of degrees after top dead center, ATDC. So if the piston is approaching the bottom of the cylinder, then we have left top dead center, so it's after top dead center. If the piston is on its way up to top dead center, then we some amount of degrees before top dead center. That is our reference point. All right, so let's go through the 4-stroke power cycle. So we said we have our cycle must have intake, compression, fuel injection, power, and exhaust. And then the cycle repeats itself, right? So, so the intake stroke begins after finishing the exhaust stroke. So at this point, so we just finished the exhaust stroke, and now we're starting the cycle over. So the intake stroke, and once again, we're talking about a 4-stroke power cycle here. So as the piston moves upward on its way to top dead center, this exhaust valve is open. As it begins to keep moving upward, the intake valve opens. This is the air intake valve. So fresh air is entering. So fresh air enters. And exhaust gases leave. So at this point, we're scavenging. We're getting rid of the last bit of exhaust. So the exhaust valve is open, and fresh air begins to enter this cylinder. So after the piston passes top dead center, the downward movement of the piston creates a suction that draws fresh air in. So after the piston passes top dead center, which is the highest point, and it is on its way down, it creates a suction and fresh air enters the cylinder. And then the exhaust valve will begin to close and then fully closes. So as that piston continues to go down, more fresh air enters in. So at this point, the exhaust valve is closed. You see the valve is seated against it. And after it reaches bottom dead center and is on its way up, the intake valve starts to close. And as the piston is moving up, because now we're on the compression stroke, the air is compressed. We'll say per the compression ratio. And as the air is compressed, it starts to get hotter. Let's say this piston moves upward. Both intake and exhaust valves are closed, and the temperature and pressure of the air increase. Due to the decrease in volume caused by the piston moving towards top dead center. So now we're headed into the fuel injection step. So at this point, both valves are closed. The piston has been moving upward. The air is being compressed. And the fuel injection starts right before the piston reaches top dead center. So the fuel injector sprays the fuel into the cylinder. And the piston continues its upward movement. So the piston reaches top dead center as the fuel is still being sprayed, and then begins moving downward again. And right after it reaches top dead center and on its downward stroke, fuel injection ends. The diesel fuel that was sprayed into the hot compressed air begins to burn, which causes the, we'll say, expansion work, which pushes the piston downward. So now we're on the power stroke. Once again, both valves are closed. The piston had been moving upward. The fresh air was compressed. The fuel has now been injected and is starting to burn. So, like we said, after the piston passes top dead center, the fuel injection stops, and the heat released by the ignition of the fuel causes a rise in pressure. This pressure pushes the piston downward. This downward action from the fuel ignition applies the force to the crankshaft, which is the power stroke. So then, after or during the power stroke, the piston is moving downwards and towards the end of this downward stroke, the exhaust valve, as you can see here, begins to open. Which lets exhaust or the waste gases escape the chamber cylinder. The piston then begins to move upwards towards top dead center, and continues allow the exhaust gases to escape. And right before the piston reaches top dead center, the intake valve opens and the cycle starts again. So, in quick summary, as piston moves up, forces exhaust gases, let's say, forces exhaust gases out, then the intake valve starts to open. Piston on its way down. Draws more fresh air in. Exhaust valve begins to close. Piston on its way up. Air begins to get compressed as both exhaust and intake valves are closed. Right before piston reaches top dead center, fuel is sprayed into chamber. As piston heads down, fuel injection ends. The expansion due to ignition of the fuel delivers power to crankshaft. And exhaust valve starts to open. Piston then heads up. Forces exhaust out, and intake valve begins to open. Cycle begins again. So it's 4-stroke cycle. So just like the 4-stroke cycle, the 2-stroke cycle must go through the same 5 events of intake, compression, fuel injection, power, and exhaust. These are requirements of the stroke. The difference being there are only 2 strokes here. Top dead center to bottom dead center, and then bottom dead center to top dead center. These 2 strokes are called compression stroke and power stroke. So in the 2-stroke engine, intake the piston is near bottom dead center, and exhaust is still in progress. The intake valve or ports open, and fresh air is forced in. Exhaust valve is closed, and intake continues. Then the compression begins. Piston is moving upwards to top dead center. This is after both exhaust valves and intake valves are closed. Here, the fresh air is heated by compression. Fuel ejection then occurs as the piston is nearing top dead center. Fuel is sprayed to the chamber. Power, the piston passes top dead center, and the expanding gases from the ignition force the piston down, which rotates the crankshaft. And for the exhaust, as the piston nears bottom dead center, the exhaust valves open and exhaust gases leave the cylinder. So for two-stroke engines, only about 38% of the generated power is harnessed to do work. %32 is lost in the exhaust. Four-stroke engines, about 42% generated power is harnessed. Let's talk about fuel controls. control of a diesel engine is accomplished by the following components. We have a camshaft, fuel injector, and the governor. As we said previously, the camshaft provides the timing needed to properly adjust let's say that better. It provides the timing needed to properly inject the fuel the fuel injector is the component that measures and injects the fuel, and the governor regulates the amount of fuel that the injector is to inject. So camshafts provide the timing and pumping action used by the injector to inject the fuel. Fuel injectors measure the amount of fuel injected into the cylinder. The governor determines the amount of fuel required to maintain the desired engine speed and adjusts the amount to be injected by adjusting the position of the fuel rack. diesel engine speed is controlled solely by the amount of fuel injected into the engine by the injectors. Diesel engines require both a means of changing engine speed and a means of maintaining engine speed. So the governor is a speed sensitive device designed to maintain a constant engine speed regardless of load variation. Let's talk about starting circuits. Diesel engines are commonly started by air motors, electric motors, hydraulic motors, manually, etc. The following events are required. The start signal is sent to the starting motor, which will engage the engine's flywheel. 2, the starting motor will crank the engine, which means it will spin the engine a high enough RPM to allow the engine's compression to ignite the fuel and start the engine running. Number 3, the engine then accelerate to idle speed and the starting motor will disengage from the flywheel when it is overdriven by the running engine motor. Diesel protection systems. You have overspeed devices, overspeed devices act to cut off fuel to the engine and alarm at certain preset RPM This is because a failure in the governor injection system or sudden loss of load could cause the diesel engine to overspeed. This overspeeding could cause the engine to fly apart. If water jacket, water-cooled engines can overheat if the cooling water fails to remove excess waste heat removal of the waste heat prevents the engine from seizing due to excessive expansion of the components under a high temperature condition. The water jacket temperature sensors provide early warning of abnormal engine temperature usually by alarm indication. Low oil pressure or loss of oil pressure can destroy an engine. The oil pressure sensor usually stops an engine one set point serves as an alarm function. The second step point can be set to shut down the engine before damage is done. Okay, this concludes our study of diesel engines. Please send me an email if there are any questions. Enjoy the rest of your day. Be safe.